Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mior Muhammad Hakimi bin Mior Burhanuddin. My metric number is DE190177.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aunia Fika binti Omar, AE190022.
Assalamualaikum, my name is Haris Saifuddin bin Hairudin, AE190005.
Assalamualaikum. My name is Fitri Muhaimin. My metric number is AE190065.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifah Nukalisha binti Khalid. My metric number is AE190057.
For question 1A, we need to find partial derivative for dv per dt. We use a formula dv per dt equal to dv per dx times dx per dt plus dv per dy times dy per dt plus dv per dz times dz per dt. So firstly, we need to find dv per dz. We use a chain rule formula, and then same goes to dv per dy and dv per dz. And then we find a differential of x, y and z. Lastly, we add to a formula and we get the answer. Question 1b, we need to prove that x times dz per dx plus y times dz per dy is equal to 1. So to find dz per dx, we use a formula. Shade ln x is equal to fx prime over fx. And then we get dz per dx. Same goes to dz per dy. We add to a equation and we get x squared plus y squared over x squared plus y squared. So it means its proof is equal to 1. For question 1c, we need to find dz per dx and dz per dy. For first equation, firstly, we derivative with respect of x, use a product rule, and then we get dz per dx. And then we derivative with respect of y, use the product rule, and we get dz per dy. For second equation, we derivative both of sides with respect of x, and we get dz per dx. And same goes to dz per dy, we derivative by use respect of y.
So this is the simulation for question 2a. The question asks us to sketch the region bounded by the equation for the first quadrant. So this is the equation given. By this equation, we can get the radius is 2 and the second radius is 5. Then we can plot on the graph. So this is the area bounded. So next, we need to evaluate the double integrate based on the interval from the region in Q2a. So this is the conversion formula from Cartesian coordinate to polar coordinate. So this is the formula and the interval we've got from the region above, 5 and 2. And then these two formula we replace into the equation, and then we integrate and we got the answer. And the next integration, we got the interval is pi over 2 and 0. Then we integrate, we got the answer 609 over 8. For question 2b, we need to sketch the cylinder and its projection on suitable plane. The equation was given. The first equation is x squared plus y squared equal to 16, and we know the radius is 4. And next, x equal to 4 and x equal to -5. Based on the equation, we can sketch the cylinder. Next, we need to evaluate the triple integral using any suitable coordinate system for the boundary condition in question 2b. This is the first equation, the interval we've cut from the cylinder above, 4 and -5, then we integrate. And this is the second integration, the interval is 4 and 0, then we integrate. This is the last integration, the interval is 2 pi and 0, then we integrate and we got the last answer, 3 at 4 pi. So this is the simulation for question 2a. The question asks us to sketch the region bounded by the equation for the first quadrant. So this is the equation given. By this equation we can get the radius is 2 and the second radius is 5. Then we can plot on the graph. So this is the area bounded. So next we need to evaluate the double integrate based on the interval from the region in Q2A. So this is the conversion formula from Cartesian coordinate to polar coordinate. So this is the formula and the interval we've got from the region above 5 and 2, and then these two formula we replace into the equation, and then we integrate and we got the answer. And the next integration we got the interval is pi over 2 and 0, then we integrate, we got the answer 609 over 8. For question 2b, we need to sketch the cylinder and its projection on suitable plane. The equation was given. The first equation is x squared plus y squared equal to 16, and we know the radius is 4. And next, x equal to 4 and x equal to negative 5. Based on the equation, we can sketch the cylinder. Next, we need to evaluate the triple integral using any suitable coordinate system for the boundary condition in question 2b. This is the first equation, the interval we've cut from the cylinder above, 4 and negative 5, then we integrate. And this is the second integration, the interval is 4 and 0, then we integrate. This is the last integration, the interval is 2 pi and 0, then we integrate and we got the last answer, 3 and 4 pi.
Question 3a. Compute the work done of the force Fsy to Si plus y square j in order to move the particle from the point 0, 0 to 39 along the following curve. So the first curve is the y equal to 3x. So in the simulation, we find the r. We got the ti plus 3tj, and we differentiate it. The r, we got the I plus to 3j. We get find the dot product of the f multiplied with the dr. Got a 3y square plus 2x, and we substitute the x equal to t and y equal to 3t. From the r, we got the 37t square plus 2t, and integrate it, the limit of the 3 until the 0, we got the 252. This is same for the question 3a2. We got also same as well, and with the same step we got the 252 also. Question 3b, find the potential function of the f. So in the simulation, we got the for the curl f we got the 0, and for the del multiplied with pi we got the in this equation. For we compare it for x, for between I and j. For the I we got the x squared, and for the equation for j we got the 1 over 3 y cube, and we combine it, two of them, we got that x squared plus 1 over 3 y efficiency. Find the work done. So work done for the equation pi sy and s2 y2 and s1 y1 v minus u, and then we get the 252 also. Okay, for the last question for the 3, find the surface integral from the plane s plus y plus z equal to 9. So this we're gonna draw the for 3D this one, and then find the graph the 2D from the z axis, find this plane, and then this plane, this equation we got it from this, and then find the area of the top of the z axis, we got the square root of the 3, and then this equation for the last question we got the surface integral with the double integration of dy and dx. We got as well 81 over 2 multiplied with square root of the 3.
Okay, Assalamualaikum. So right now I will present about the simulation for question 4a1, which is we are using Stokes theorem for this question. So the first thing is we plot the graph for the paraboloid and the plane z1 right here. This is the plotting. So next thing is we initialize the value for the velocity field and the parabola equation, and we differentiate it with respect of x and y, and we initialize the value of x and y in this equation before integrate from 0 to 1 and 0 to 2 pi. The evaluation we get is 7.85. This is the equation we insert it to the multiplication of 180, which is with the value of pi, and we get the value for the degree, which is 450 degree. So next thing is we insert the value of z and f, and we get the k, which is -1. And the last thing is we get the flux value, which is 270 degree, which is the same as 3/2 pi. Okay, for the next, we use the Gauss theorem, which is the same. We get the same answer, which is 3 pi over 2. But this is this is the whole simulation. It's very simple compared to the previous one. So this is all from me. Sorry for the short. Uh, Thank you.
Okay, so I will continue with 4b. From the question, we can plot the graph as like this. So we will continue with the calculation. So z equals to r, and then x equals to r cos theta, and then y equals to r sin theta. And then we double integrate r square plus xz minus yz, and then we will get the final answer as pi over 2 plus 2 bracket cos over 4 minus sin over 4 pi square.